All right, here we go. Here are the answers for today's lesson, 7.6, practice A, the even questions. So if you watch the Anywhere Math video and you remember from a couple weeks ago, what we want to do with these inequalities is just like with equations, we want to isolate the variable, which means we need to use the inverse operation to get the variable by itself. So in this particular lesson, you're going to be using either addition or subtraction. Okay, remember it's the opposite of what's being presented. So in number 2, where the original inequality was v plus 10 is less than or equal to 14, you would be subtracting 10 from both sides to be left with the v is less than or equal to 4. Okay, we'll go back and do the graphing. I'm just going to go over the solutions first. Number 4, you would be adding 3 to both sides to end up with x is greater than 11. In number 6, you would be adding 1/5 to both sides. What you end up with is 1 or 5/5 is less than or equal to m. In number 8, you would be subtracting 2.4 from both sides to get an answer of 2 is greater than b. In 10, you would be subtracting 16 from both sides to get a is greater than or equal to 9. In 12, you would be adding 19 to both sides to get y is less than 70. Okay? In number 14, you had to write the phrase as an inequality, and then you also needed to solve the inequality. So in number 14, it says 4 less than a number, so we have to have x minus 4, not 4 minus x. And again, your variable doesn't matter. Okay? X minus 4 is greater than 3. Okay? And then in number 16, the phrase is the sum of a number and 14, so that's addition, is at least 18. It has to be at least 18. 18 is the minimum, so it would be greater than or equal to 18. Okay, so let's go back to our graphing. Okay, here are the solutions that you should have. The first part, solve the inequality. But now let's do the graphing. So if we think back to the graphing, we had 3 main things to think about. Where is the dot going to go on the number line? The dot is always going to go at the point in which it's being compared. Okay, v is being compared to 4. X is being compared to 11. Those are the locations of the dot. The next thing we need to decide is it an open dot or a closed dot? Okay, and really that is determining on what type of symbol we have. Okay, if we have a traditional greater than or less than symbol, it is an open dot. It means that 11 in this situation is not a possibility for x. Okay, x has to be greater than 11. It cannot be 11, okay? Whereas with these types of inequality symbols, the or equal to, that's where we have a closed dot, okay? So if you need a little trick to remember, that's what we're looking at. And then the final thing to consider with these number lines is, or the graphing of it, is which way does the arrow go? The arrow represents what v could be or what x could be. So that is the direction in which the arrow needs to go, okay? So in question number 2, if I have v is less than or equal to 4, my location is 4, okay? I'll put a 0 just to give some context, but I don't need to stress about these number lines too much. It is going to be a closed dot, and it's saying that v is less than, and the less than numbers are off to the left-hand side, okay? In number 4, x is greater than 11. Again, I'll put a 0 just for some context. I'm going to have an open circle this time, and it's greater than 11, so my arrow is going off to the right. In number 6, be careful when your variable's on the right. We want to make sure that we're reading it with your variable first. So I can read it this way, 1 is less than or equal to m, but I can also read it the other way. M is greater than or equal to 1. So again, a 0 just for context. I'm going to have a closed dot, and m is greater than or equal to 1, so it's going off to the right. Okay, double check that one. When we have a variable that's on the right-hand side, we tend to get some arrows going the incorrect way. Number 8, I'm going to put a 0 just for context. My dot is going at 2. It is going to be an open dot, and b is less than 2. So I'm going this way. In number 10, A is greater than or equal to 9. Okay, so I'm going to have a closed dot at 9. It's greater than or equal to, so my arrow is going off to the right. And in number 12, Y is less than 70. I'm going to have an open dot at 70, and it's less than, so my arrow is going off to the left. Okay, remember you can always pause and go back if you need to. Okay, in questions 14 and 16, first thing was translate this into an inequality. Next thing is solve. Okay, so we want to get x by itself. I want to add 4 to both sides of my inequality. The minus 4 plus 4 cancels out just like it did with equations. What I'm left with is x is greater than 7. And then in number 16, I want to subtract 14 from both sides. These cancel out. I have x is greater than or equal to 4. Okay? And your two other questions that you were left with, number 18, the error analysis. They subtracted 5 on the left-hand side, but they added 5 on the right-hand side. You don't want to do that. You want to make sure you're subtracting on both sides. You're doing the same things to both sides. And then in number 20, it goes on to say that in order from the bookstore takes at least 4 weeks to arrive. That's a really slow bookstore. You ordered some books online 9 days ago. Write and solve an inequality to represent the possible number of days it will take for your book to arrive. Okay? So the first thing we want to think about is 4 weeks, which is 28 days. Okay? That is the minimum. It says at least 28 days. 28 days is the minimum it could be. Okay? Which means it could take longer. So whatever the time is that it takes, this is the smallest number it could be. It's 28, okay? We already have waited 9 days, and we're waiting an unknown number of days, okay? So here's our written inequality, and what we'd want to do is subtract 9 from both sides, and what we're left with is 17, right? Yes, no, 19. Whoops, sorry, 19 is less than or equal to D, meaning I'm waiting at least 19 more days for these books. Okay, it could be more. Okay, so hopefully that answered some of your questions. If you did not tune in to the live chat that we just had, I will be hosting that live chat as well. So hopefully we can continue to practice this. The isolating portion, the solving portion, hopefully is a little bit more straightforward. We've been working on that since before we left with isolating a variable. It's the graphing portion that we might need a little bit more practice with. So again, feel free to rewatch, feel free to email me with any questions, and have a good night.